This is going to be a tutorial on 3-2-2-2-3 edge pairing for the 4x4. The method used by Faz, which is one of the fastest 4x4 cubers in the world, and this is basically how it starts. Once you finish your centers, you're going to first look to see how many edges you have already solved. Right now I already have one edge solved, so that means for the first step, instead of pairing 3 edges, I'd pair 2, that way I end up with 3 edges. But for the sake of this tutorial, I'll go ahead and make this one of my 3 edge pairs. So the first thing you want to do is you're going to want to slice the middle layer, either left or either clockwise or counterclockwise. It does not really matter. So now when I slice back, I already know that this is going to make a red-black pair. Okay, so now I'm going to look for the blue-orange, which is right there. So it's already going to make a pair there too. So yellow-green, which is right there. So I'd rotate the cube, place the yellow-green, and when I rotate back, I now have 3 edge pairs. 1, 2, 3. Okay, now I'm going to start the 2 edge pairing part, which is just like normal edge pairing. So I see the red-blue, so I'm going to place the red-blue, and now I've already noticed that the green-red is right there, so I'm going to do a flip, create the blue-red edge pair, replace it with the green-red, that way when I slice back I make a second pair, and that is a 2-part. That's 2. So I'm just going to repeat that, green and black pair, and now blue and black is right here, so blue and black is going to need to go right here on the bottom part, and blue and black is right here, and that creates that. So that's the second 2 out of 3. So now I'm going to do the green-orange, which is right there and right there, and when I slice back, orange and black is right here, so replace it again, create the orange and black pair. Now the final part is the final 3. So I'll do a red and yellow, slice, orange and yellow needs to go on bottom, and then there's my edges completed. This one I got lucky because the first set of 3 already had 2 edges completed. So I'm going to go ahead and then so sometimes you'll end up with only 2 edge pairs, which is normal. So you just basically do the same algorithm, which is you slice over, right, up, reverse right, front, reverse right, reverse front, right, up, and that'll switch 2 edge pairs. So and then, so let's do a walkthrough solve real fast. Okay, create the orange pair, create the red, black, okay, and again I got 1 edge pair solved, so I'll go ahead and take that out, that way I can show you a full one. Okay, so right now there's no edge pairs solved. Okay, so again you're going to start off with a slice, okay, and now green and black, green and orange, that's not a good combination, so you're going to want to slice the other direction to avoid having that, because then you can't do 2 edge pairs. So you're going to slice the other direction. Okay, so green and black, so that means green and black need to go right here. So, okay, and now when I slice back, I'll create 2. So that's pretty much most of it done so far. Okay, now I need to do the green and red, which is right here, and it needs to go right here. So I place that. Okay, and that creates 3 edge pairs. 1, 2, 3, which is the first edge pair. In the second one, you're going to look for either a white and green, or a yellow and green, or a yellow and red. There's none in the top layer, so therefore they're both going to be in the bottom layer. And I use this one because it doesn't require cube rotation for either the red yellow or the green yellow part. So then I slice over, creating the red yellow pair, meaning I'm going to need the green yellow to be right here, it's actually right here right now. So I just do that, and now it's placed. Okay, so now both red and black or red and blue, or black and blue are not on the top. So now I switch over, and this one's going to require cube rotation, or you can do like something like that. So place the red and black on bottom, place it, place the blue and black on bottom, slice back, creating a second 2. Okay, orange and black. This is, if you notice right now, I got orange and black, and orange and green, orange and black, orange and green. This is, it's not really a parity, but for the method, I consider it sort of like a parity, because you're going to end up with a set of 2 at the end. So for this, just place it and put in any unsolved edge in. Okay, and then do the other one. So right now, orange and black, orange and yellow, orange and yellow. Okay, and this is where the parity, or the 2 edge comes in. Red and blue, yellow and blue, yellow and blue. So the algorithm: slice over, right, up, reverse right, front, reverse right, reverse front, right, up. And then that's your edges solved. So from now you'll just basically solve the 4x4 the way you would solve a 3x3. Okay, come across to the parity, the OLL parity. It's right, up 2, cube rotation, right, up 2, right, up 2, reverse right, up 2, left, up 2, reverse right, up 2, right, up 2, reverse right, up 2, reverse right. It'll be in the description, along with the algorithm for the other part. Okay, this is just a normal thing. Okay, so now you have your 2 PLL parities, which the first one is when 2 opposite edges are switched. Okay, you're going to do a setup move, or if up 2, to where they're opposite from each other. It doesn't really matter. I do the up 2 first instead of at the end, because sometimes it saves me a turn earlier on if I catch it earlier enough. Okay, and then you're going to do little R2, up 2, little R2, big up 2, little R2, big up 2. And that'll solve that one. And in order to do the second edge parity, where you have 2 adjacent edges switched, you're going to do a cube rotation of a right 2, reverse front. And then you're going to do the algorithm: up 2, little r, up 2, little r, big U, little r, big U, and then you're going to do front, right 2, and that solves that. And there's also parts where you'll have 2 corners switched, or you'll have basically 2 corners switched. So you can do one of these 2 edge switches and you'll end up with a standard PLL, or you can look up online and try to find corner switching parity algorithms. I hope this tutorial helps anybody out who's confused with the 3-2-2-2-3 method of edge pairing, and hope to see you again.